We'll explain about the introduction, and then conventional flip voltage power circuit, and then related research, bucket driven MOSFET, and then first and second proposed circuit, and simulation result, and the last is conclusion. Okay, now I will start the explanation about the introduction. We know that the analog clock, is the one of key component in analog or mixed signal LSI chip. And suppose this is the LSI chip. One of the most important thing here is the signal transmission between the analog clock. And to make this transmission be possible, the voltage follower are needed here. And we usually realize this voltage follower using operational amplifier with negative feedback, but it occupies a large chip area and consumes a large amount of power. So it is very difficult to realize many op-amp in one chip. Copy the IDS3 to IDS1, so we get IDS1 equal to IDS3. And this is the equation of IDS1, and this is the equation of IDS3. From these three equations, we will get that V out equal to V in minus VT minus VSS. Add two transistors M6 and M7 here, and use depletion MOSFET here. M6 and M7 are used to enlarge the input range, because by use M6 and M7, VT here can be optimized not only by M2 but also by M6 and M7. And next is using depletion MOSFET. We know that N-type depletion MOSFET have a negative threshold voltage, so we can operate N depletion MOSFET in saturation region under the condition VGS equal to 0. In this case, we operate M3 here in saturation region under the condition VGS equal to 0. And then my presentation. Thank you. Actually, the first problem is narrow input range and offset voltage. And this problem can be solved using this research. This is the previous research of WDV student. Using this circuit, the problem can be solved. However, this depletion MOSFET cannot be implemented in standard CMOS process. So this circuit will need higher cost if we fabricate. And the next circuit is this circuit. This is this circuit using floating gate MOSFET. And the floating gate MOSFET need a large chip area. So my aim is to eliminate the offset voltage, but can be realized and also decrease the chip area. And using the bucket technique, I can eliminate the offset voltage, and the chip area issue is smaller than this circuit, and can be fabricated in ordinary fabrication process, so the cost will be low. Actually no, but if we use a large area in chip, we will get difficulties to implant another circuit in the chip. So by small chip area, we can get many circuits in one chip.
But how did you guess the cost?
The cost is depend on standard on special fabrication. So actually the cost of fabrication process, this circuit and my circuit is just the same. But this circuit occupies a larger chip area. So if we use this circuit, the area of the chip will be larger, and we cannot implant another circuit. But this circuit cannot be fabricated in ordinary fabrication process. So this circuit must be fabricated in special fabrication process, which can fabricate the plasma VT, and this is higher cost.
Even now, the plenty of voltage follower is used in many electrical circuits. So you mean that all of those conventional voltage follower should be replaced by your proposed circuit?
I don't mean like that. I mean that.
So what is probably you going to propose some special purpose or circuits to be used?
I mean usually we realize the voltage follower using operational amplifier with negative feedback, but it consumes a large amount of power and occupies a large chip area. So if we want to realize many op-amp or many voltage follower in one chip, it is very difficult, or it will consume a large amount of power. To overcome the problem, previously there is flip voltage follower is proposed to overcome this problem. But the conventional flip voltage follower has these disadvantages. So my research is how to solve this problem.
I understand your purpose, but actually, you are going to propose to replace all of the VA used in the current ULSI should be replaced?
Actually, if I want to replace, it is yes, but not now. Because if we want to replace, we have to expand my circuit to the class AP, and it is the future work. But in the future work, it is possible, but now it is not visible yet.
Please show me the table of the consumption power. So, power consumption for the conventional ones use only 1 microwatt. And if someone replace to your new proposed circuit, the power consumption becomes almost 30 times more. That means that you need the more energy, the power. So that's the reason of my question. So even you you propose to replace it?
Actually, the most problem of this circuit is narrow input length and the offset voltage, and it restricts any application. So if we just use the conventional one, we cannot use this conventional voltage follower in many applications. So although the conventional one have a low power consumption, this circuit cannot be implemented in many applications. But by use this proposed circuit, yes, of course, this power consumption is much larger than the conventional one. But this proposed circuit can be implemented in many applications because the offset voltage is 0 and the input range is larger than the conventional one.